Hi, this is question 5 from the AQA Further Pure for June 2009 exam paper. The points A, B, C and D have position vectors A, B, C and D respectively relative to the origin, where these are the values of A, B, C and D. So these are the vectors of A, B, C and D. What we're going to do is we're going to use scalar triple products to first of all show that they are coplanar. And then we're going to find the volume of the parallelepiped defined by AB, AC and AD. So we're just going to deal with part A first of all. Okay, so we already have the vectors OA, OB and OC. To show that they are coplanar, we need to find the scalar triple product, so that A dot B cross C, and we're trying to show that that's equal to 0, and that's what will show that they are coplanar. Okay, so to do A dot B cross C, I'm going to put these together to form a matrix that I'm going to find the determinant of. So I'm going to have 2, 1, 4, 3, 2, 5, 1, -1, 5. You could have just done B cross C and then dotted it with A. This is essentially exactly the same thing. So I'll carry on, and we have got 2 times 10, 5, and then I've taken away 1 times 15, take away 5, and I'm going to add on 4 times -3, take away 2. It seems like a bit of a hassle to write all this out, and quite often you'll be tempted to take shortcuts. The biggest error that people make in FP4 are sign errors. I think that is the thing that you're going to fall down on. So it's worth investing that extra bit of time just to write it out, so that you're clear about exactly what you're doing. So if I carry this on now, that's going to be 2 times 15, which is 30, take away 10, and take away 20, and that's going to be equal to 0. So therefore coplanar. Right, part 2 of A is find the volume of the parallelepiped defined by AB, AC and AD. So we first of all need to find the vectors AB, AC and AD. So AB is going to be B take away A, so that's going to be 1, 1, 1. AC is going to be C take away A, which is -1, -2, 1, and AD is going to be D take away A, which is 3, 4, 7. Okay, and again we want to do the scalar triple product of those to find the volume of the parallelepiped, and I'm going to write it as a determinant. And that's going to give me 1 times 14, take away 4, take away 1 times 7, take away 3, and plus 1 times -4 plus 6. So that's going to be -18 plus plus 10. That gives me negative 6. Okay. Now we need to be careful here because it's asking us to find the volume of the parallelepiped defined by AB, AC and AD, and because we've got a negative 6, we need to make sure that we say what our volume is, and our volume can't be a negative number, so we would have to say that our volume is going to be 6 units cubed. Okay, so so there we go for part A. I'm just going to tidy that up and then we can have a look at part B. Push part A over there. Right, okay, so for part B, we're asked to find the direction ratios of the line BD. Okay, so I first of all need to find the direction of the line BD. Okay, so I'm going to do D take away B to work that out. So that's going to be 2, 3 and 6. Okay, so the direction ratio is going to be Okay, the direction ratio is going to be the ratio between the x, the y and the z. So that's going to be 2 to 3 to 6, and it's as simple as that. So that's the direction ratio of the line BD. The next part, we want to deduce the direction cosine of the line BD. So that's the cosine of the angles that this line is making with the x-axis, the y-axis and the z-axis. So if this was our x-axis here, for example, we want the cosine of the angle that this line is making with the x-axis. So I know that if I go 2 across, I'm going to have the magnitude of 2, 3 and 6 that is going to be the length of this hypotenuse here. So that would be my adjacent side. The magnitude of this vector would be my hypotenuse side. Just put x there so we know that's the x direction. Then the cosine of the angle would be the adjacent divided by the hypotenuse. For the y, so if this was my y, then I've got 3 there, and then the hypotenuse again is going to be the magnitude of this line here, because that's going to be the length of the line. And then similarly, just to finish off, z, it will be the same scenario. Again, that would be 6, and the magnitude of that line would make up the hypotenuse. Okay, so I need to find what the magnitude of BD is, and that's going to be the square root of 2 squared plus 3 squared plus 6 squared, and that's going to be the square root of 4 add 9, which is 13, add 36, which is 49, which gives us 7. So my direction cosines, well, in the x direction it's going to be 2, the adjacent divided by the hypotenuse, so that's going to be 2/7. In the y direction that's going to be 3/7, and in the z direction that's going to be 6/7. Okay, so there we have it. Thanks for joining me. I'll see you next time.